Fingerprint recognition using feature extraction. So what I'm going to study about is like what is a fingerprint, what is fingerprint recognition, the various fingerprint recognition techniques, the dataset that I used, and my approach, that is my algorithm that I used to recognize fingerprints, the evaluation, and the conclusion. So what is exactly a fingerprint? Like fingerprint is a unique feature that separates different human beings from each other. Fingerprints are a representation of ridges and the furrows on the finger, as you can see in the images. What is a fingerprint recognition? So, fingerprint recognition refers to an automated method of verifying a match between two human fingerprints. It is one of the forms of biometrics used to identify an individual and verify their identity. Like at immigrations, um, at border security, the officers take your fingerprints to verify that that belongs to you. In iPhones, the home button has an inbuilt finger recognition system which helps the user to enter his phone if it belongs to him only. And fingerprints are highly reliable for the identification because of the uniqueness and consistency over the time. The fingerprint recognition can be divided into two parts. One is the verification, and then is identification. In the verification, all the features of the fingerprints are extracted, and in the identification process, the features that are extracted are matched with the previously stored features, so as to verify if the fingerprint belongs to the same person. Though the three fingerprint matching techniques that I like that are is image-based matching, correlation-based matching, and a minute-based matching. I have implemented a minute-based matching in my algorithm. The dataset that I have used is taken from FEC 2004 fingerprint verification competition. It has about 8 different fingerprint images of the same finger of 10 different people. Each image has a size of 388 cross 374, that is 142 kilopixels. So in the implementation of minute-based matching has two domains. One of them is minute extraction, and the other one is minute matching. So in the minute extraction extracts the minute features from the image by first enhancing the image so that the image looks clearer, and then by segmenting the image to remove the unnecessary data that were generated in image enhancing. After that, the minute extraction process performs the thinning of the ridges so that the ridges are consistent all along and removes the false minute that were generated along the way. And then is the minute matching. In minute matching, minute sets were generated when enhancing and extracting and segmenting the fingerprint. So these generated minute sets are compared with the previously stored minute sets, and a similarity score is generated which tells if the two fingerprints of the people belong to the same person or not. In my algorithm, if the threshold, that is 0.48, if the similarity score is greater than 0.48, then the fingerprint belongs to the same person, otherwise it doesn't. In the evaluation, like from my algorithm, a false rejection report and a false acceptance rate is generated, and a curve is plotted between them, as you can see in the graph. As you can see, as soon as the FMR gets reduced to 0, there is a point, that is my threshold, over which each and every image belongs to the same person. According to my algorithm, the accuracy that is coming out to be 70%. So conclusion, the algorithm helps to recognize different biometrics of different human beings. It includes extraction of minutes and matching of them. A similarity score is generated which tells if the fingerprints are similar and generates a score if it's greater than 0.8. A high false rejection rate and a incorrect acceptance rate tells algorithm is not as efficient as it could be with using different techniques, as it is vulnerable if the images are of bad quality or scaled or deformed. Thank you. Fingerprint recognition process using feature extraction The dataset that I have calculated is FVC 2004, and it has the fingerprints of 10 different people with 8 images each. So the first thing that we're going to do is we're going to build a database by extracting the features from all the images and storing them in a file called dbmat. So in feature extraction, the first thing that happens is image enhancement. So under image enhancement, all the images are expanded to look much more clearer. Then there's image segmentation. So like all the necessary things from the images are removed. The third thing is minute extraction. So the minutes that were generated that were in the image are extracted using an algorithm. So let's go ahead. So this will take like approximately 30 minutes to like extract all the features from all the images and storing them in the database. As you can see, it has extracted the features from the first image for the first person. It is doing for the second image for the first person, and it will go on and do it for the rest of the people. We're gonna skip this for now. So the second thing that we're gonna do is we're gonna will generate a false matching report. A false matching report tells us the error uh, and the acceptance rate. And in this algorithm, the all the images, all the minute pairs, all the features that were extracted was loaded, and they're compared with each and every image, so as to generate a familiarity score. So let's go ahead. So the FMR generated, and it is compared with the false non-matching report. As you can see, it is loading up the database, and it's computing, and it's storing it in fmr.mat and fmmr.mat. FMR is false matching report, and FMMR is a false non-matching report. So at the point where the false matching report goes 0 in the graph, that is set as a threshold. So if the similarity score is greater than a threshold, then the images belong to the same person, otherwise they don't. This will take like approximately about an hour. So let's get that now. This will generate the graph for FMR and FNMR. It will take all the values. It will load up the FMR.mat and FNMR.mat and will generate a graph for that. As you can see over here, the FMR reduces to 0 at this point, and this is set as a threshold. If the two images have a similarity score greater than 0.48, then they belong to the same person. So like if you're given an image and we are told to compare it with a single image, so image enhancement is taking place, then segmentation will take place, and then it will find the minute features and will compare them. As you can see, the red ones are the minute features of the original image, and the blue ones are the minute features of the fingerprint that we matched. If the minute features align themselves accordingly, like if the minute features are extracted, and the first thing that we do in minute matching is we align the images so that they look the same, and then we compare. If the minute features are the same, then the image and the similarity score is greater than 0.48, the image belong to the same person. If you are given like a single image and we are said to compare it with all the images in the database, see, it will load the db.mat and will compare each and this image with each and every image in the database. So this will it is extracting the features from the original image that we're going to test and is going to compare with each and every image in the database. It is extracting the features and now it's comparing the similarity score. As you can see over here, it's going to take like approximately 2 or 3 minutes to compare the images. It's gonna just take time, like just 1 more minute, and it will finish up comparing all the images, and will show us the similarities. It's showing us the similarity scores over here, and it will tell us like how many images does this image match with. Okay, now as you can see, the image is 1001.tif, and uh, all these images are all these images still here are belong to the same person. As you can see, the similarity score is greater than 0.48 for each and every one of them. It means they belong to the same person. This is the fingerprint of the second person. As you can see, the similarity score is less than 0.48 for each and every one of the images over here. This means that they belong to the different person. As you can see, the match rate fingerprints are 1, 2, 3, 4, 5, 6, 7, and 8. So, and now you can see the code. And thank you.